So this is tutorial 8 for Python. There's statistical calculations, and in this tutorial we're going to do 4 different statistical calculations. The first one being average, then we're going to do median, then we're going to do range, and finally we're going to do standard deviation. The average is calculated by calculating the sum of all of the items in the list and then dividing the sum by the number of items in the list. Okay, before we calculate the average, we're going to look at the program I've got set up here. You'll see that I'm importing math, which I'll need in order to do some functions. I'm also importing a random, so I can generate random numbers. And you can see here that I've also created a list that I can use as my test data. So this is just my sum list. And then I'm going to do this section of code here. You'll need to copy this in. To do your test, what it does is it creates a random number of items in the array. You'll notice that it's going to do some within a range between 30 and 75 twice, and then some within the full range of 0 to 100 once. So for every time this loops through, I'm putting 3 numbers in, but 2 of them are within a range, and 1 of them is outside of the range, but it might be or it might not be outside of the range. And that's how I'm going to create a typical data set that I like to see, which has a number of items around a specific range, while the rest are sort of a bit more randomized. Now we've got this counter, it's going to add up, so it's going to go through and do it 60 times. I've also got this extra comment here, I'll put a space there, so that I can actually add an extra element to the array. This is going to be 60. If I want 61, so I want to make my array odd, that would be useful to do that. So I want to basically just change the length of my array by 1. That's what I'm going to do. And then I'm going to print out the array, and I'm also printing out the length of the array. And then I've got this section down here, a section where I'm going to define functions, and a section where I'm going to put the main programs, which is just at this stage just going to do outputting. So I'm going to run this just so you can see what happens. And I get my array here in random order, and I get the length equals 60. So that's what we're starting off with. So let's now calculate the average. You can see that the average is calculated by the sum of all the items in the list, and we're going to then divide the number of items in the list. So let's do that straight away. So we're going to define a function called getAverage, and into that function we're going to pass in a list. In which case, inside this one, we're going to use the variable the list. The list is what we're getting the average of. So first of all, we're going to calculate the sum of all the items in the list. So we need a variable to hold the sum of items. And the sum of items will currently be equal to 0 from when we start. And then we say for each item in the list, the list is lowercase, better to select it out of there because it makes me type it right. We can say the sum of items plus equals each item. So each item is going to be added to that value as we go through. And then we're going to basically say that the average is going to be equal to the sum of, oh hang on, we should basically put this on the other side of this comment. Just press Command X. Okay, so we'll put it on the other side of this comment, Control V, is sum of items divided by the length of the list. And then finally what we can do, I've got a bit of a funny thing happening there. Then what we can do is we can return the average. We'll go down to our main program now, and we can say, I'm just going to say print. I might put in just a whole bunch of lines, just so I can get a separation there. And I'm going to say print, and then I'm going to say the average is, and then we'll add the string value of getAverage for our test data, which is sum list. Okay, so we can see there we're going to pass that in. So if we run this, provided we've done it all right. The average is 46.25. Now if I run this again, I've got a nice number this time around. You'll see that the number is huge and long. I don't want that, so what I'm going to do is I'm going to put in here a round that number, and I'm going to round it to 2 decimal places. So my average is just always calculated to 2 decimal places, and now I'm going to run it. So it's always going to be 2 decimal places. The average is 2 decimal places. Let's just spell that right. Okay, so that's how we calculate the average. The median is the middle item in the list, so we need to first sort the list so that we can find the middle of it. We then pick the middle item, and if there are an even number of items in the list, we need to actually realize that there are 2 middle items in that list. Therefore, we will take the average, or the difference between those two, or the distance between those two, divided by 2. And if there is an odd number of items in the list, we just simply pick the middle item. So we've created a function called def get median, and we're passing in the list. The first thing we need to do inside this function is sort the median. So I'm going to type in the list dot sort. Now this is not going to sort this one up here. Sorry, the function, the sum list, it's not going to sort that. It's just going to sort the list, which will be a copy of sum list. So basically we're going to use that, and then we're going to pick the middle item. So we'll say a middle item is equal to, and it's just the index, so middle index, let's call it middle index, not middle item, is equal to the length of the list divided by 2. Not that way, I did it the last time, that way. Okay, so length of the list divided by 2. Now, if there are an odd number of items in the list, we need to treat it one way, and if there are an even number of items in the list, so I'm going to indent these guys here, and we're going to basically say if, let's just find for the odd number of items in the, the even number of items in the list first. So if the length of the list, okay, divided by 2, sorry, not divided by 2, percent 2 equals 0, so the remainder, if it's divided by 2, should be 0, then we'll do the even thing. So the even thing is here, and the even one, it'll be, we're going to set the middle index equal to the integer of the middle index, because it actually comes out as a float, and we don't want to use a float for an index. And our median, the median, is going to therefore be equal to, I'm going to open a bracket here, and I'm going to say the list of the middle index plus the list of the middle index minus 1. That's why I was saying minus, because I had to take 1 off it. And the whole thing there is then going to be divided by 2. So it's going to be the average of those 2 items, or the halfway point between those 2 items, is going to be the median in this case. But there's another case here, so we can say else, if the odd number of items in the list, then we can just say the median is equal to the list, and the index is going to be math.floor of the middle index. Okay, so we've calculated the middle index. In this case, it'll be a number which actually doesn't make sense because it's an even number, so we need to find the middle number between those 2 even numbers, because there's no middle value of an even numbered list. Otherwise, there is an odd number of items in the list. So now all we need to do is we need to return the median, and we'll test this first of all by changing this number here to 3. which will give us a smaller number of items in the array. So I'm going to run without debugging. And you can see that the length is 9. And we need to actually give some output here. So we'll copy this, Control C, Control V. The median is get median. Okay, now run it and see. Okay, so the median is 64. And you can see here, I need to actually have the array sorted out. So I'm going to just above here, for the time being, print sum list dot sort, and I'm going to run this. I can't do it like that. Control X. I'll say sorted is equal to, and now I'm going to print sorted. Okay, now if I run, okay, that's not working for some reason. I'll just do it like this. Okay, so here we go. So the median is 52 in this case. There are 4 items on this side and 4 items on this side. So the median is 52, which makes sense. And if I actually add this one in, which is why I've got it here, this comment, and I run this now, you'll see that the median is 49.5 because these 2 items here are the middle numbers, and there are 4 items each side, and halfway between 48 and 51 is 49.5. So that is working well. I'm just going to get rid of that print statement now. I'll just comment it out, and I'm going to also put this back up to 20, and I'll run that again just to make sure that I haven't created an error, which I haven't. So now I've got the average is 53.61 and the median value is 57. So that's the median has been calculated. It's now time to calculate the range, and the range is done by sorting the list and then subtracting the first item in the list with the last item in the sorted list. It's now time to sort get the range. So the first thing we're going to do is sort the list dot sort. And because it's easy to do, you do it every single time. You don't sort it once, you sort it every single time you can. It's going to be a small list anyway. If it was like a massive list of gigabytes of data, you'd definitely sort it once and then use it. But we're not doing that. We're basically just sorting it once. And then we're going to subtract the first item in the sorted list from the last item in the sorted list. So we could basically say the range is going to be equal to the last item in the list is what we're going to subtract it from. So the last item in the list is the list, and it's going to be the item number of a length of the list, but it's going to be subtracted by 1 because the length of the list is always, so for example, the length of this list was 61, but the first array is 0. Item in the array is 0, so therefore the last is 60, so it's always minus 1. And then we need to subtract the first item in the list, and the first item in the list is always 0. So that is the range, and the range, I'm going to return that now, the range, and now we're returning the range. We'll put something down here, we'll copy and paste this line here, Control C, Control V. The range is, and we're going to say get range sum list. So that should work. Let's just run it and see. The range is 91, and if we look at our list there, I'm sure if you actually put it in order, it will be easier to see this. But basically, it'll be the largest number minus the smallest number. It looks like the smallest number is a 0, so therefore the highest number is probably a 91. No, smallest number is not a 0. Smallest number is, can't find it, but it's in there somewhere. So that's definitely working. Range of 91 definitely looks right, at least anyway. You might want to test that by using a smaller values of the array, so you can just basically make sure that that's working. Standard deviation provides you with a distance from the average, which most approximately 70% of all items will appear inside, and which basically helps you to know if a value is outside of what you'd normally expect. So it's basically the normal range is the standard deviation range, and outside of that standard deviation range is what you would consider exceptional. And you can use this to look for things, so for example, like you've recorded a lot of times for running 5 kilometers, and if you see an exceptional one, say for example it's way too low, then you might be able to take that out because you might have misused or mistimed yourself. And if it's too high, it might have been that you had to stop in the middle for some strange reason, but you can take those out, or you can actually treat those as exceptional cases and then try and understand the implications of exceptional cases in that particular set of data. So we've got to calculate the difference of each item from the average, and then we calculate the sum of the square of the difference values, and then we calculate the square root of the average of the sum. So you can see that's a little bit more involved than the other ones. It actually involves some of the other ones, so we need to be able to use the other ones within that. Okay, so what I'm going to do here is I'm going to basically get a few things set up first. The first thing I'll do is I'm going to take the list, I'm going to sort it. The reason why I'm going to sort it is it just makes it just a little bit nicer for me to be able to see if I need to debug it. So basically the other thing I need is the average of the list. So I need the average because I need to do some comparing of the average from the list equals, so I basically say that equals to get average, because we've already done this. This is our own little function that we've written from the list. So I'm going to pass the list into there, and what that's going to do is we're going to run this code, and then this code is going to run the average code, which is up here, and then it will return it back here. So basically we've got the average. We need the average for that. Now the first thing we're going to do is also create a difference for each item, and we need to do it for the square of each item. So I'm going to basically change things around from what it said here, but basically we're going to go through and we're going to say I'm going to create a list of square differences. Okay, and that is going to be equal to some random list. Then for each item in the list, what we're going to do is we're going to add or append to the list of the square differences dot append, and we're going to append the square of the difference from each item from the average. So we're going to take the power. That's how is a nice way of doing square. And what goes inside here will be each item subtracting the average, and we're going to do this to the power of 2. So we're going to take that value, we're going to put it to the power of 2, and then we're going to whack that into this square differences array. For purposes of debugging, let's actually print this out. So we won't print it out there because it'll print out too many times. But we're going to print out the list of square differences in the array, and we're going to run this without debugging. And oh, we haven't called it. Let's call it down here. Let's just say get standard deviation sum list. Now let's run that, and we've got an error. Oh, what have I done there? Dot sort. I'm using an old different language. Okay, let's run that. So you can see there that there's this massive, great big array. For some reason, it's got those values in there. I'm just going to look at that for a second. Yep, that makes sense. There's nothing wrong with that. So that is what we've got so far. So now I need to get the average of the list of square differences. So I can basically say, let's just call it square averages. Square averages. Averages is equal to get average, we're using get average again, of the list of square differences. Let's just print out the square averages, just so we can see what's happening. You can see I'm taking a bit more time with this one because it's a little bit tricky, but basically the average there. So the standard deviation is going to be the square of that. So if I say the standard STD DEV is equal to, actually I'll do it nicely so I can actually manage. The standard deviation is equal to math dot square root of square averages, and then we can say print the standard deviation, and if we run this now, it gives a standard deviation of around about 17, which is what I've typically been getting, plus or minus a few. So let's fix this up. Let's get rid of all these print statements now. I might just comment those out. Actually, no, I'm going to get rid of them. I'm going to delete them totally. And I don't want that one. And I don't want that one. Now I could have done this all in one step, but I didn't. So now I'm just going to actually just Control X there, and let's get rid of these comments altogether actually, because I did it slightly different way to what I said because it didn't make sense to actually do it that way within the software. So now I can just say return the standard deviation, and now I can actually just copy this, Control C, Control V, and the standard is that, and let's just say we'll go get standard deviation of some list, get rid of that one there because I don't want to print that out again, and let's run this now. Okay, so the standard deviation is that. I probably don't really want that number there, so basically I'm going to say the standard deviation equals round of the math.square, and I'm going to round it to 2 decimal places. So let's just run that, and now I've got the average being 56, the median being 57, the range is 94, and the standard deviation is 17.72. If I wanted to play around with that standard deviation a bit, I could probably go from this one here and make this one a bit more within the range of the average. So let's just say that from 40 to 65, and that will bring the standard deviation out a bit. Shouldn't have done that, it should have brought it in. If I do this 40 to 65, yeah, there you go, it's brought it in now. So that's basically bringing the standard deviation in a little bit, and some people like their standard deviation to be close, and other times they want it to be further away if they want numbers to be a certain way, so we're just manipulating the input data to see what it's going to look like. If, for example, I was to comment this one out and comment this one out and just make this 1,000 just to be sure. I'm going to run this now. So the standard deviation is 28 between 100, and you can see that the median, and so it's spot on average is around about 50, which is what you'd expect the computer to do to get an average around about a perfect number. The range is 100, which you'd expect in 1,000 choices for it to get a 0 and 100. And what you'd also expect the standard deviation to be about 30% of either side of the thing, which basically means 2/3 are in and 1/3 is out. So there'll be basically a pretty good random range there. So we can see there's all my numbers. But I'm going to bias that back in, put the bias back in, so that the list is biased around a range. And that is a nice way of actually doing some test data, is just to be able to play with the biases in the input range, so that we can get some nice testing of our thing to see if what we're getting is what we expect. So that's a good analysis of the number of integers in a list by calculating the average, the median, the range, and the standard deviation of those items within the list.